All right, so you know what equivalent fractions means, I think. Why is that so crooked today? For example, if I were to give you 34 over 18. What would you do? What would you tell me you can do with 34 over 18? You can reduce it, and you can divide by 2. So you would write it as 17 over 9. Okay. So when can you reduce like that? What allows you to reduce that fraction? When there's a common what? Common factor. All right, so we can reduce when there is a common factor. So what you're doing here, and when it's just numbers, you've done this so much that you really do it in your head. What you're really doing is you're saying, all right, I can take 34 and I can write it as 2 times 17, and I can take 18 and I can write it as 2 times 9. I have a 2 on top and a 2 on bottom. Those are common factors. I can reduce those out, and that's 17 over 9. And like I say, for the most part, you simply do that in your head. You don't even show the step at all. What if I gave you 5 plus 9 over 10? Can you reduce the 5 and the 10? I hear a vote for yes and a vote for no. All right, well, first off, let's simplify this. If I were to simplify, what would the order of operations tell me to do? Add first. So that would be 14 over 10. Can I reduce 14 over 10? Yes, and I get 7 over 5. All right, so now if I take 5 plus 9 over 10, can I reduce that 5 and that 10? Okay, what do I have left on top? Well, down on bottom, I think you'd say you have a 2. How about on top? 5, it reduces with a 1. All right, so this is not the right answer because we end up with 10 over 2. 10 over 2 is 5. Is 5 the same as 5/7? All right, so we cannot reduce that way. I cannot reduce the 5 and the 10. Why not? Do I have a common factor? No. What does the word factor mean? What does it mean to say we have a common factor? Like up here, we could reduce the 2's. Yeah, it means a number that can be taken out. In other words, I need to go to multiply. Here, this 2 is a common factor because it's 2 times 17. 2 times 9. 5 plus 9, that's not a factor. That's a summation. So I can't reduce over plus signs like that. I can only reduce across multiplies. So if I had something like 5 plus 20 over 10, notice up on top I could factor a 5 out. I could write that as 5 times 1 plus 4 over 10. And now I can reduce this 5 with that 5 because now this 5 is a factor. It's something connected by multiply. The only time you can reduce things in a fraction is when they're connected by multiply. You can never reduce them when they're connected by add or subtract. Never, ever, ever. So this time we can reduce. That would be a 1, that would be a 2. And our final answer would be 5 over 2. Questions on that? All right, well, of course, the bad news is, in this section, our fractions that we're going to be reducing are not just going to have numbers, they're also going to have, oh, even worse than decimals, letters. They're going to have variables in them, that's correct. So I might ask you to reduce X plus 2 over X. And you would tell me? 3X? No? No? It's a trick question. You cannot reduce it. She's learning about primes. Why can you not reduce that? The top does not factor. The bottom does not factor. When can you reduce? You can only reduce when you have common factors. So if you cannot factor the top and you cannot factor the bottom, then you cannot reduce. Again, it's very tempting to cross out that X with that X. You can't do that. Why not? They're connected with add, isn't it? This X right here is connected by an add. It's not connected by a multiply. So this was a trick question, and that's mean to do on the very first one. But it said a good point. Sometimes you can't. So the answer is, it is reduced. I can't reduce it any further. However, if I changed it just slightly, reduce to X over X, that one you would tell me, oh, that one I can reduce. How can you reduce that one? This time you can cross out the X's. Why can you cross out the X's? Because it's connected by multiply, which means X is a factor. X is the only thing down there. This one we can reduce the X's, and our answer would be 2. Questions on that? All right. So it's important to know when you can reduce and when you can't. Sometimes you just can't, and that's okay. Reduce. X squared minus 4 over X squared minus 5X plus 6. Can I reduce the X squared with the X squared? No, why not? It's not common what? You got the right idea. I was looking for a specific word. It's not a common factor. How come X squared is not a common factor? It's connected to other things by subtraction. I guess they're both subtraction and addition. To be a common factor means it's something that's being multiplied. X squared is a common term, but that doesn't do us any good. In order to reduce, we've got to have common factors. Oh, I am, and I'm going to have you reverse FOIL the numerator too. So that's exactly what we're going to do. So this is part of why we learned how to factor the last couple days. In order to reduce fractions like this, you have to factor. So you're exactly right. We're going to factor the bottom, we're going to factor the top, and we're going to see if there's any common factors. If there are, we'll reduce them. If there aren't, then we did a whole bunch of work, and it's frustrating because you had to do a whole bunch of factor and nothing reduced out anyway. But that can happen. All right, so factor the top for me. X plus 2 and X minus 2. Factor the bottom for me. X minus 2 and X minus 3. Are there any common factors? Yeah, now there are common factors. They're factors because they're connected by multiply to other things. So those reduce out. And our final answer would be X plus 2 over X minus 3. Questions on that? All right, let's deal some problems out of the book here. Let's see. Oh, I got some good ones. How about reduce? 6 minus 3t over 4t cubed minus 8t squared. Any good suggestions on what to do? Sit in the corner and cry. That's not a good suggestion. It's not a productive suggestion as far as answering this problem. Maybe it's a good idea, but not a productive idea. Other ideas. Question your existence. Let's start with the bottom. Can you factor the bottom? Yeah. They have a common term, don't they? They have a common factor of 4t squared. So I'm going to take out 4t squared. What's left over? T minus 2. How about up on top? Factor out of 3. Here's what I would do instead. Factoring out of 3 is not a bad idea. What I notice about the top is it's written in the wrong order. What do I mean it's written in the wrong order? Usually we put t's first and numbers at the end. Or if there were t squared, normally we put the squares first and then the t's and then the numbers. So what I would do first is I would switch that around. I would write it as minus 3t plus 6. I would switch the order. Put it in the right order. And then I would look to factor. What can you factor out? What's common? Right. When this first thing is a negative, typically we factor out a negative. So up on top, I would factor out a negative 3. And when I factor out negative 3, what's left up there? When you factor out, it changes the sign in the middle, t minus 2. Because I need negative 3 times negative 2 to give me back that positive 6 I had at the beginning. All right. So watch out for that. Sometimes things are written in the wrong order. If they're written in the wrong order, switch them around, put them in the right order. And then if the first thing is a negative, factor out a negative. Do we have any common factors? T minus 2, those reduce out. So that is negative 3 over 4t squared. Questions on that one? All right, reduce. Like a mean one here. Three y cubed plus 7y squared plus 4y divided by y squared plus 5y plus 4. What's that? On bottom, I certainly do reverse FOIL. Okay. Y plus 4 and y plus 1. Don't know why I wrote that in the opposite order, but I did. Doesn't really matter. What about up on top? Factor out a y. Excellent. 3y squared plus 7y plus 4. All right, can I reduce anything? Well, I can't reduce yet. You're right. I think I still need to do more. I think I need to do more factoring on top and reverse FOIL that one. I can use the group method if I choose. If I choose. All right. So, here's a little trick on these. That I would usually use. I'm going to have that y. We factored that. These problems are almost always rigged so that you're guaranteed that something will reduce. So most likely either the y plus 1 or the y plus 4 is going to reduce out. And so a lot of times with these problems I skip the grouping method and I actually use the guessing method because the guessing method can go faster. So I'm going to guess, I don't know which one's going to cancel out, but I'm going to guess it's y plus 4. So if I put y plus 4 here, then I have to have a 3y to get a y times a 3y to give me 3y squared. And then I need a 4 times a 1 to get a 4. And then the only question is, do I get the right thing in the middle? And I can do a quick outer and inner. On the outer I would have y. On the inner I would have 12y. Y and 12y gives 13y, so unfortunately I made a bad guess. Alright, so then I would try again, and I would say, alright, well the y plus 4 isn't going to be the one that cancels out. Let's try the y plus 1. If I put y plus 1 there, then I would need a 3y plus 4 to get the 3y squared in front, to get the 4 in the end, and then I check and I have a 4 and a 3y. That does give the 7y back. So when you're doing these, a lot of times if you factor everything that's easy to factor first, the things that don't have the 1 in front, factoring the other ones can be easier by the guessing method, because you can guess that something's going to cancel out for you. And then the guessing method becomes pretty quick then. So I tend to use the guessing method, the guess and check method, a lot more in these problems than I do if the directions just say factor, because then I don't have any basis of really making a good guess. Alright, so the y plus 1s reduce out. So it looks like my final answer has a y on top, a 3y plus 4 on top, and a y plus 4 down on the bottom, and that's the best I can do. Questions on that? Alright, so that's our first section for today on equivalent fractions. Second one is section 6.6. Multiply and divide fractions. Alright, so again, let's just start with numbers. How do you multiply two fractions? If I gave you 3/8 and told you to multiply by 12/9. All right, there's two ways to go. One is to multiply fractions. You simply multiply tops, multiply bottoms. All right, so I multiply the tops. What's 12 times 3? 36. 9 times 8. And then I look to reduce. 36 over 72. Can I reduce it all? I can reduce by 8. 8 times 4 is 36? No. It happens to reduce by 36, because 72 divided by 36 happens to be a really nice number, happens to be 2. So it happens to reduce to 1/2. That's one way to do it. Multiply tops, multiply bottoms, and then reduce at the end. Anybody got a different way? Reduce first, and that's the way I prefer to do it. If I have 3/8 and 12/9, the rules are you can reduce straight up and down, or you can reduce diagonally. So what I mean by diagonally is I see a 3 on top and a 9 on bottom. I can reduce those. That's a 1 and that's a 3. And then I see straight up and down a 12 on top and a 3 on bottom. That reduces by 3 to be a 4 and a 1. And then finally I see a 4 on top and an 8 on bottom. 1 and 2. So what's left? 1 on top and 2 on bottom. 1 over 2. For this problem, doing it that way almost seemed like more work. But usually doing it this way is better, I think. And why do I think doing it this way is usually better? Yeah, I'd rather deal with little numbers like 3 and 8 and 12 and 9 than big numbers like 36 and 72. Little numbers are very easy for me to reduce. The bigger the numbers, the harder it gets. Okay? So I tend to reduce first, multiply later. Either way gets you the right answer. All right, how do you divide two fractions? How do you take, I don't know, 21 over 15 and divide by 9/10? You flip the second one, and it changes to multiply. All right, so what you're telling me is this becomes 21 over 15 times 10 over 9. I flip the second one, and it changes to multiply. All right, and then again, you have two choices at this point. You can either multiply tops and multiply bottoms, and then reduce, or you can reduce first, and then multiply. And again, personally, I like to reduce first. It makes all my numbers smaller. I see a 10 on top and a 15 on bottom. Those reduces by 5 to a 2 and 3. What else do I see? 21 and 9 can reduce by 3. That'll give me a 7 and a 3. And I think that's it. I don't see anything else on top that reduces with anything else on bottom. So my final answer is 14 over 9. And again, my personal opinion is that's a lot easier than taking 210 and dividing it by whatever 15 times 9 is, and then trying to reduce the fraction with the big numbers. I think it's much, much easier to reduce first. Do I care which way you do it? No, not really. Whichever way is better for you is fine with me. Fraction is better. Well, what's going to happen in this section? We're not going to have just numbers, we're going to have letters. That's correct. So we might have something like, again, stealing some problems out of the book here, 4x plus 12 divided by 5 times 5t over 3x plus 9. How would you begin? Look for anything that can be reduced. Do you see anything right away? The 5 right away can be reduced. All right. Anything else right away that can be reduced? No, I don't think so. But what can I do? I could factor 4x plus 12. How would you factor that? Take a 4 out. All right. So I'm going to factor. I'm going to take a 4 out. That's going to leave x plus 3. And I already reduced the bottom. There's only a 1 left on there. Times, up on top, there's just a t left. And how about the bottom? Take out a 3, and what's left over? X plus 3. Now I see some common factors. I see those two things knocking right out. 4t over 3. Very good. So multiplying fractions really isn't any different than what we did in 6.5 when we reduced fractions. It's just there's going to be more pieces to factor and more things that can reduce. That's all. How about 2a plus 8 over 15 divided by a squared plus 8a plus 16 all over 125. Flip first. Correct. The first thing you do when you see a division of fractions is you flip. So you just write it all down again. 2a plus 8 over 15 times 125 over a squared plus 8a plus 16. Reverse FOIL the long one. A plus 4, a plus 4. What about this one up here? Take out a 2. So we factor. To sum it all up in one word, we factor. We take a 2 out here. Left over is a plus 4 divided by 15 times 125 over, you told me this one's a plus 4 and a plus 4? That looks right. Okay, reduce away for me. A plus 4 reduces with an a plus 4. Anything else? 15 and 125 can both be divided by 5. So 15 divided by 5 is a 3. 125 divided by 5 is 25. Looks like our final answer is 50 over 3. I would leave it in factored form. Again, it would not be wrong to write it as 3a plus 12. When I did all that work to factor, I don't want to unfactor. So typically we would leave it factored like that. Again, if you wrote it as 3a plus 12, I wouldn't mark it wrong. It's fine. It's correct. You can leave it like that. Just in case you need to do something else, yeah, we leave it factored. And something else will start showing up in the next section. What are we going to do? Why are we learning to multiply and divide these fractions? What's that good for? Absolutely nothing. No, that's not completed. We'll get to that. All right, one more for me. Let me find a hard one here. Oh, yeah, there's a good one. How about x squared minus 6x plus 5 over 4x squared minus 17x minus 15 times 6x plus 21 over 2x squared plus 5x minus 7. Make sure I copied it down right, because if you don't copy it down right, you almost never get the right answer. Suggestions on what to do? Well, I don't need to flip anything, do I? Because that's already a multiply. It's already a multiply. A lot of factoring. All right. So again, I start by factoring the things that are easy. So I think x squared minus 6x plus 5 is easy to factor. X minus 5 and x minus 1. And then how about 6x plus 21? I think that's pretty easy too. Take a 2, and it's 3x plus 7. No? 2's not common, is it? Oh, yeah. Take out a 3, and then it's 2x plus 7. All right, now what about the bottoms? 4x minus 5, he's guessing. And x minus 3. What's that? The signs are incorrect because unfortunately minus 5 times minus 3 gives a plus 15. So that's not the correct answer. Ugh. That's the downside of the guessing game. Sometimes you guess and you get it wrong. So, maybe we better do that one by the grouping method? Too late. I already said grouping. I'm going to do it by grouping. Just to review that. All right. So I would probably go off to the side here and deal with this thing. 4x squared minus 17x minus 15. That grouping method again, how did that work? You multiply the first number times the last number. What's 4 times negative 15? Negative 60. And then we have to factor negative 16. And we need those factors to add up to be that number in the middle, which was a negative 17. negative 20 plus 3. Those will certainly multiply to give a negative 60, and they add to give a negative 17. That's a good choice, I think. All right, so that's going to be 4x squared minus 20x plus 3x minus 15. First group, I can take a 4x out, and I'm left with x minus 5. Second group, I can take out a 3 x minus 5. So the x minus 5 is common, so that's an x minus 5 and a 4x plus 3, which is what I think he had on the second guess. So x minus 5 and 4x plus 3. And again, you'll notice that these problems are almost always set up so that something's going to cancel out. Those x minus 5s are going to reduce straight up and down. So the second one, again, I could do the grouping method, but I'm going to take a guess. And I'm going to take a guess that 2x plus 7 is going to reduce with 2x plus 7. And then let's just see if I can make it work. 2x times what to get a 2x squared? An x. And a 7 times what to give me a negative 7? A negative 1. Now the only thing is, does my middle come out right? On the outside I would have a negative 2x. On the inside I would have a positive 7x. Those do add up to 5. So again, quite often with these problems, you can use the guessing method, guess that the problem is rigged for stuff to cancel out, and it can save you some time rather than doing that grouping method. Does it always work? No, of course not. It doesn't always work, but a lot of times it will. So, yes, we got some cool stuff here. The 2x plus 7 goes with the 2x plus 7, and the x minus 1 goes with the x minus 1, doesn't it? So there's not a whole heck of a lot left. What's left? 3 on top, and 4x plus 3 down on bottom. Questions?